Hello friends, welcome back to another session of Docker. In this session we will learn about uh, storage and volumes. So before to start with the storage and volume, we need to create one image first, because from the image we are only creating the containers. So what is that image? This image we are creating on top of Ubuntu 22.04 label. That is okay. You can give any maintenance who is owning this Docker file, you can give the name. Okay. Then we are just updating our system repository. Then we are installing JDK 17, open JDK 17, and then we are adding my web app var file, and we are exposing the port number 5050. So what is there in this my web app 1.0.var file? First we will see that. So this is our Spring Boot application only. If you see, this is a fat jar. This is nothing but a fat jar. So this is our Spring Boot application. If you see, this is our Spring Boot application, that whatever we are going to add. So I will explore this first. What all are dependencies there, what are the configuration there, how many repositories are there, all we will see first. So first observe the pom.xml for this file. If you open the pom.xml, we have Spring Boot starter and Spring Boot starter Tomcat. That's it. Spring Boot starter web starter is there, and embedded Tomcat starter is there. That's it. Okay, in the pom.xml, this much configuration. And if you go to if you go to your package, so under package you have a controller. So I am moving to this controller. It's okay, you can move to controller. So controller, I am moving to this controller package. So this is your controller. Under this controller we have created one logger. If you see, this is not a REST controller. This is a simple simple HTML simple MVC controller. In that one we are creating one logger factory.get logger, and by passing this controller class, and there is a one default URL, that is an index. Here we are giving welcome message, and we are printing that welcome message. Means we are logging this message in our log file. Currently, if you see this log.info, where it will write as per your logger configuration. If you have not specified any appender for the logger, the default appender is your console appender. So it will append in the console. If you have specified in your application.properties, it will accordingly add the log in that file. So we have given our log files. This is the path of our log file. In this path I want to log the messages, and message pattern something like this one. First it should be level, then logger, and then message, then line number, something like that. Root level, the level is info. After info, the lower level, all level, it will log. Okay, and this is your view resolver, simple view resolver HTML. That's it. You are giving fine, and this is okay. And in your logger, in your my controller, if you see, we are returning index and another, these two files we are returning. So what is this, what is this index and another? This is your view file, this is your HTML files. Where it is, where is it, where it is? Under src, under src main web, under web, if you see, under web app another and index.html files are there. Okay, so this is returning index and another only, that's it. Okay, so this is a straightforward code. You can very easily, you can understand it very easily, you can understand this. Simply just we are logging, when we are calling the home URL back forward slash, this is your index URL. When we are calling index URL, we are logging welcome message and showing index page. When we are sending request as a show another, then we are first logging welcome, then we are logging showing another page. So this is just, it should log in this file. The statement should be logged into my logs web app dot log, my web app dot log. Under this one it should log, under this one it should log. Okay, we will observe this, we will see whether is there any file on this one at this location or not. So how will you see it? You have to go to your terminal and type here pwd. It will tell what is your present working directory. So present working directory, home tech hub, this is your present working directory. Now you have to go to at the root again. Okay, now if you see, present working directory is your root directory. What is our path that we have specified? Our path is root path slash. In this root, my logs folder is there, it should be there. If it's not there, you need to create it. So ls, it is listing all the directories are available under this one. So there are a lot of directories: bin, root, cd-rom, dev, etc, home, lib32, lib64, libx32, lost plus found, media, mnt, my logs. Yes, it is there. opt, proc, root, run, svl, sys, user, temp, user, var, sys. So these all are the root, the directory structure of Linux operating system. If you are using Windows operating system, in Windows the directory structure something is different. In your Windows operating system, C drive, D drive, like that will be there. There will be a C drive. In that C drive you have installed operating system. There will be D drive where you are keeping your files. There may be another drive, E, C, D, E, F, n number of drives from your hard disk. You can create the partition. But in Linux, the root path will be there only. This under this root path, these are the default libraries, like user defined libraries, directory structure. These directory structure is used by your operating system. Yeah, even my logs I have created separately to store the logs file, or else wherever you want to store the logs, you can create a folder or you can create a directory and you can store your logs in that one. I am preferring to choose at the root directory. I am creating my logs, that's it. Or whatever the name you want to give, you can give. Just for learning purpose, I have given my logs so that we will understand. Here I am trying to write my logs, that's it. Okay, fine. So this is your directory structure. So go to the my labs now, cd dot my logs. Now we moved to my logs. Now if I see here ls, so there is no directory. It means ls means it is list, it is listing what, all the files, like files that can be a directory, it can be another file. So all it is listing. Currently there is nothing, there is no directory, no file in my logs folder. So there it is ls returning null, no values. Okay, so that's okay. So it is storing into this location, the logs will be stored at this location. That's it. And this is your my controller. Okay, that's it, this much only. This is simple Spring Boot class, boot main class only. That's it. Fine. So what I can do, I will build this again once again, because we have updated, we have moved this my controller controller class from this root package actually. So that's why I am building once again. Okay, build is successful. So minimize this one, and now go and copy that. Go to here, under workspace, Eclipse, under Eclipse my web app, under web app target, under target you can see my web app 1.0.var is there. Copy this, and you have to paste in your Docker, this one, replace it. Okay, so now this is your updated one, my web app 1.0.var. Even this is old one, my web app jar, my web app var, that is old one, I am not using. Here I am giving the my web app 1.0.var. This is a new one. Okay, fine. So open your Docker file. Now open your Docker file and copy paste this Docker file code once. Copy this and paste it. So what we are doing, simple, same approach. On top of Ubuntu 22.04, what we are doing, we are creating a image. We are creating our image on top of Ubuntu 22.04. Here I am giving the owner of the file, then I am updating the system property, then I am installing OpenJDK 17, then I am adding my web app 1.0.var, my web app 1.0.var file I am adding, and then I am exposing the port. What is the port? Of our application? See, our application port is 5050, because our application server is listening at 5050 port number. That's why we are specifying, we are exposing 5050, and then simply I am running java jar web app. So what if I run that here? Can I run that one? Can I run it? Java jar my web app, what is the name? My web app 1.0.var. That's it. It should run your server. Yeah, it is running. You can see it is running. Okay. So your application is started. It is telling Tomcat started on ports 5050 with default context path. Okay, fine. Okay, so can we go and see whether the file is created? What if I will execute ls here again? So you can see here my web app one folder is there. So what it is preparing, see, under root directory my logs is there. Under my logs, my web app folder is there. You can see here. You can see here. So go to cd dot my web app. Now if you see present working directory, what is your directory path? At the root directory, my logs folder is there. Inside my logs, my web app is there. Under my web app, what it should be? Under my web app dot log file should be there. So just see whether it is there or not. Yes, it is there. How many contents are there in this log my web app dot log? How can you see it? Cat my web app dot log. You can see here. These many contents are there in this log file. Tomcat started on 5050. That's it. And then this one, in this much time it's started. That's only. This same we are getting at this path also. Okay, that's it. It's starting from here. Starting my web app 1.0.var. See, starting web app.var. Okay, fine. That is, this is not your logger one. This is not your logger one. You can see here. How can you identify whether this is a logger or not? It is not in logger. Why it is not in logger? Because it should log here the logging level. There is no logging level. There is no logging level. Okay, so that might be some simple SOP statements. Okay, fine. So what I will do now, I will open my browser and I will go to localhost 5050. What it is doing now, it is hitting to the home URL. So inside home URL, what we are doing, what we are logging, we are logging these values. This is because this logger has a both two appender. One is console appender and the file appender we have explicitly added. Default appender is your console appender. So console appender is printing here, and file appender we have added. So go and check in the file. How will you check in the file? Same, execute the same command, and you can see it is added in the logger also. Okay, fine. If I hit another URL, like another, so it should come what? Now what it should come? After this one, welcome. If I see again, after this should be welcome, and then showing another page. It should be something like that. You can see welcome showing another page. This is added, and if you observe here, it's added here. Okay, that's it. Do Control Z, so you can stop your server. Okay, the server is stopped now. You can see here. If I will refresh this one, it will go, because this server is stopped. Okay, fine. Clear it. Close this one. So this is clear now. What is the use of this logger and where this log is residing in your operating system. Now you create an image from this web application var. Okay, create a container for this one. So open this one, go to open terminal here, and first see how many images are there. Okay, so how will you see the images? I want to create image from this Docker file, because in this Docker file I am adding my web app 1.0 var, that is logging to that directory, that is logging to this directory. this application my web app 1.0 var is logging to this directory my logs my web app dot log. Okay, fine. So will it create this my logs folder, or we need to create it? It will create. Okay, we'll see it. We'll see. If it's not creating, then what we need to do? We need to create here. We can create here also. Okay, but we'll see it. Okay. Fine. So first create the container. Create the image. So how many images are there? How will you see? Docker image list. There is a Docker image list, not images. Docker image ls. There is a my web app and container repository oracle.com database free. This is I'm not deleting this image currently because this is a Oracle database related image I have added. If you see the size, this is huge in size. So if I delete this, remove this image, and again I have to download, it will take a lot of time, and again I have to do the setup. So I'm not removing this image. You just don't consider this image. This is just Oracle database image. Instead of installing the Oracle database in your machine step by step, better you use the Docker image. So I'm doing that one. We'll see this in after this session. We will see, or I think after Kubernetes we will see about this database. But currently you don't consider. So there is one other image is there. I'm deleting this one. Docker image remove, and this one just remove it. Okay, it's deleted. Okay, clear it, and now see how many containers are there. Docker psa, how many means all containers. So there is only one container. This is a Oracle DB container. Okay, from that Oracle database image I have created a container. Okay, so leave it. Fine, clear. Now I have to create the create the image from this Docker file. Okay, so how will you do it? Docker image build, build image name my web app 1.0. okay, and dot, I think this much is enough. Dot represent this current directory. In this current directory, what your Docker will do, your Docker will search for Docker file with the name Docker file. Yeah, it is there. Start building. Okay, or else if you, instead of dot, if you want to give the other locations, other directory location, like any other folder, any other inside any other file, Docker file is there, or with the file name is there, you can give that one. But currently it's not required. So press enter. So yeah, it is building the image from this file. So Ubuntu 22.4 it is downloading, then it is installing. Okay, so let's wait. It will install. It will update the system. Then it will install the JDK 17. So all that it will do, we'll see it. After that one, it will add our my web app. If you see our the steps, these are the steps, these all are the steps. Currently what it is doing, it is downloading Ubuntu. Then after this one, it will update the system, then it will download the OpenJDK and install, then it will add our war file. After that one, it will export the port, and this is entry point. It will run when you will run the container. Okay, fine. So the same, I think, docker image build t my web app 1.0, same, I think same we have given. Docker image build t my web app 1.0, correct only. So what it is doing now, okay, still it is okay, because Ubuntu 22.4 also has a layers, so the layers it is downloading. See, this is a one layer, another layer, another layer, this is another layer, like that, all are in the layers. See, this is another layer. Now it is updating your system. See, the second command, this one is updating your system. Okay, so it is updating. After that one, it will install OpenJDK. Okay, anyway, it will take some time. Let it be finished. Okay, now it is installing OpenJDK. Okay, see, OpenJDK. Okay, it will take some time. I think I can pause this one. When it will be finished, I will start this again. Okay, so it's downloaded. Build image is completed. So you can see here, Ubuntu is installed. First it is taking Ubuntu, and then it is updating the system, then installing OpenJDK, then it is adding the my web app.war files, and exporting the layer, that's it, and writing and naming the image to my web app 1.0. This is your docker io.library. This is from where it is getting where it is added. Okay, actually this is a name. So this is done. Now the next step, we have to create a container. So if you see this create container statement, copy this. From this image we need to create the container. So first I'm adding that file, this context here, and this is remove container. Okay, yes, so above is the container create statement. Create and run, both. Run command, what first it is creating and it is running also. D in a detached mode. D stands for run in detached mode. P means the port number, the port mapping. P stands for port mapping. Port mapping of which? What is the server port that is running on this container? Server port is 5050. So 5050 port I am mapping to 4040. Container name I am giving my C1, and this is your image. So this is correct. So what it will do, it will create the container. It will create the container, and first thing what I'm going to do, I'm deleting this file. Which file? Let me open another terminal here, and if you see your present working directory, something different. This is your present working directory. So cd dot 1 2 3 4. Okay, now your present working directory is this one. Now if you go to cd dot my logs, under my logs, if you see this one directory is there. Under this one, if you see my go to my web app. First go to my web app and then list. So delete this file. I'm going to delete this file because I want to check whether the file is there or not. Currently it won't be there because it is the application is running in container, not in our host machine. Okay, so let's delete. How can you delete it? rm remove this file. Will it work? Paste it. So it works. Removed. This file is removed now. This file is not there. Okay, clear it, and if you see there is no file. So what if I will start this container? Copy this container create statement and create and start the container. Now create and start the container. Clear it. See the images. How many images are there? So 2 images. One is Oracle database, another one is my web app 1.0. So from this my web app 1.0 only I am creating the container. So paste this containers create statement, docker container run. So it will create the container with the name my c1 and run this one. Run in detached mode. So container is running. Now if you want to see the log, how can you see the logs? So docker psa, and if you see this is your container that is up. Yeah, up 15 seconds before it is up. And if you see the docker container logs and give the logs, paste it. So it's giving the logs. Currently what is there in the logs? First the container is starting, listening on 5050 port. But can you access with the 5050 localhost 5050? Can you access this one? No. Why? Because application is not listening in this local machine. Now application is running where? Application is running on container. So we have to call to container, and container will communicate this port. So how can you do it? So for that purpose we have mapped the port 5050 is mapped to 4040. Copy this one. Okay, and see in our local running when we run this application in our local, we have seen that it is creating the file. So is it creating the file in our in our local machine? No. Why it is not creating in the file in our local machine? Because application is not deployed in local machine, that's why it's not creating. That's why it's not creating. So where this file will be creating, where the log will be stored? Let me hit the URL 4040 first. Yes, application is listening. Another page, this also working. Home page also working. So but where is the logs now? Where is the logs now? There is no log file. That is available under container. It's not available under your host machine. Under host machine you have not deployed application. Your application is deployed inside a Docker container. So you have to access the Docker container directory structure, because Docker container is nothing but this is also an operating system. This has an operating system, network, and directory structure, everything it has. So we have to enter into container first. So how can we enter? So we need to enter into the container. So how can you do? Simple. docker.container.exec interactive mode bin bash. Now we are where? We are not in our local machine terminal, we are at our container terminal. If you see here, present working directory, it is telling you are at the root directory. How many files are there in root directory? Is there any file with the my logs? Yes, it's created. See, it's created. By my logs is not the default directory in Linux. It's not the default one. It is not the default directory in your Linux operating system. It will be created when you are log, because your application has to store the log in this file only. Okay, so go to my logs. Yeah, under logs, if you see my web app is there, go to my web apps. Under my web app, if you list here, you can see my web app.log file is there. Open this file, see the content of this file. That's it. These are the content only. See, welcome. First we clicked on we access the index page, so it is showing index page. Then we have clicked on the another page. Now if I click again another page, so it is going to home page now. So definitely one more time it should come, showing another page and all. Yes, it is there. Okay, I think why it is not happening, because okay, now I want to see here show index. It should be show index. How it will be? You have to press Ctrl plus F5, because it is taking from the cache. It is not calling to the server. Now it is calling to server. Okay, showing another page. And now you click on home and click on Ctrl F5. So you can see now. Yes, welcome index page, welcome index page, two time. After another showing another page, two time came. If I refresh this once again, it will come one more time. See, three times came now after this one. So now currently where is our log? The logs are not there in our local file system. Logs are not there. Logs are available under your container. But suppose currently I am able to access this logs because container is there, and I exited from the container. And what I do currently, if you see, the container is running. This container is running. What I do, I stopped this container. So how can we do? Container dot container docker.container docker.cont container stop and container id. give the container id. Sorry, this is not the container id. This is your container id. Copy this and paste it. So container is stopped. Now container is stopped. Can you see the directory? No, you cannot see. You cannot see. But once you container start again, if you start this container, if you start this container start, if you start this container and if you enter into the container again, if you enter into this container again, you can see the directory structure and you can see the logs. You can see I'm just clearing it and I'm just pwd under this one cd dot my logs under cd my logs. If you see cd dot my logs under this one ls, one log is there and cat and simple. So you can see here again it is started. After this one we stopped the container. You can see again it's starting container and it is doing. So logs are there in this one. All the previous logs are also there because we stopped the container. After this one, after this much of the after this much logs, I stopped the container. Then I again started the container. So when I again starting the container, it is saying starting my web app application and it's starting the container. Okay, and if I again hit this request, if I control F5 again I will doing. So you can see it is adding the logs here. So this log will be available under this container only. You cannot get this log. You can do copy paste. That is a different things. But that is not the best practice. Every time whenever your application is generating some data, that data should be available if the container is up or not up. That is the best practice only. But this logs you can see only if your container is up, your container is running. Suppose your container is not able to start due to some reason, some dependency, some error in the application, something is there, your container is not able to start. How can you see the log? You cannot see the logs. Without your server starting, you cannot see the logs. But that is not the best practice. The practice is your log should be available and should be in your local host directory, in your host machine, in your local machine directory structure. The logs and not even the logs, any other application generated data should be available. So what we should do in that case, for that purpose we have to use storage and volumes. We have to use. Storage is this is storage. Means in your container you have some directory structure, you have given some directory structure. In that directory only your application is generating data. That is storage. But that storage should be available. Even if you deleted the container, if your container is not up, you deleted the container, then also that logs and any other application generated data should be available. How it is possible? That is possible through Docker. Okay, so suppose if I come out from here and stop this container. Container is stopped. Now what I will do, I will delete this. I am removing this container is not there at all. How can you see the log? This log can you see? Can you access this log? No, you cannot access. Even if you create a new container, in that container this log will not be there. This log will not be there in your container because that is separate machine. That container is nothing but same as your operating system, your computer only. You assume in your computer you have created a virtual computer. That's it. In that computer, in that directory structure, the log is not there. That's a different log because you just now you created that machine. So this now that will be similar to this situation. we have to take out the data that is created by your application outside from the container, that is called volume. So we have to use volume. Okay, fine. So these are the directory structure, the default directory structure. If you see for Linux, there are some directory structure like ext, ext4, overlay 2. There is the directory structure that is followed in Linux. In Windows, NTFS or FAT, and in Mac operating system, APFS, Apple File System. Okay, but we are not considering this one because Docker is mainly built for Linux. It's best in suitable for Linux only, because the server side everything is Linux. Okay, you no need to worry about Windows and Mac. So in your Linux, if you see, so you have to understand the directory structure of Linux first. Linux has a root directory. Under root directory there is a bin, boot, dev, etc., home, lib, media, mnt, opt, root, sub, sbin and srv, temp, user, var. Under user there will be bin, include, lib, sbin. Under var also cache, log, spool, temp, something like that will be there. Okay, like this. If you see this is your present working directory, is your root directory. Under root directory you can see ls. If you do ls, you will see how many libraries are there. See bin, dev, lib32, mint, pro. So these are the operating system library. My logs is not the operating system. This is I created to store my logs, just to show you demo. That's it. Okay, fine. So the home directory of a Docker, the installation, where it is installed, your Docker. Can you tell me where your Docker is installed? Your Docker is installed under var lib docker. You see, where is var? Where is this one? Under root directory there is a var folder. If I show you here, not in this one. If I show you here, this is your present working directory. Okay, go to cd dot dot cd dot 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 dot. Okay, so clear it. Now go to present working directory. So root directory. Under root directory, if you see, there is a var. Yes, var is there. So go to var, cd dot var. Under var, if you see, if you list again, under var there is a lib. Under var there is a lib. So where is your Docker installation? Under var lib. Go to lib now. cd lib. Under lib, if you see, so many are there. Under this one, Docker is there. Is there any file with the name Docker? Is there any file? Is there any folder with the name Docker? Search. I am not able to see. It should be there because Docker is installed at this location default. Okay. Where is that? Yes, see, this is your Docker. Okay, Docker. So go to Docker, cd docker Docker. Okay, you have to use sudo or something. You are not able to do that one. Okay. So okay, so why it is not doing like that? Okay, so I think this is protected one. You cannot see that one. Okay. Okay, but in this Docker, this is the Docker installation. Under this Docker, under this one there will be some files Docker related, like you have to create a Docker image, so images folder will be there. Under that one all images will be there. Under container, in that one container folder will be there. Under that one you have all containers will be there. We will create the volumes, so volume will be there. An upcoming session we will learn networking, so networking related components or object will be there. Okay, so this is all about the directory structure. This is the installation. Just you keep in mind, this is your installation directory of Docker. Fine. Next, here are the some description about the bin. What is the bin folder? What is the use of bin folder? Essentially user command binary, like wherever the binary files like commands you are typing, like remove file, create file, touch file, all that one will be in bin binary, essential user commands. Okay. Boot means inside this boot static files for boot loader, like whenever you are booting your application, sorry, your operating system, whenever you are pressing start key of your computer, then your computer file is booting, so that is a boot loader, so that static files will be there in the boot. Dev means device file, like if you have plugged in one mouse or keyboard or any other camera or any other printer, any devices, so that device related file will be in a dev. Etc, like host specific system configuration, system host configuration related files will be there. Home will be user directory. Home is nothing but your user directory. Okay, under home there will be users. How many users are there? That many users will be there. Same to your window. In your window, if you see under C direct drive, there will be users. In that one, how many users are there for your system? That all users folder will be there. Similar to this one also. Only under home, users name will be there. Okay. Lib will be shared file libraries. Media, removable media, any media, like you have installed, you have plugged in some device, like USB you have plugged in some, or you have plugged in your pen drive, so that is a removable media. If you have a CD-ROM or CD disk, you have plugged in something, so that is a removable device. Media will be inside media folder. MNT mounted files. OPT, add-on application software package, optional add-on application software package, whatever the application software related packages will be there, that in OPT file. SBIN, system binary file. SRV, data for service from system service is running, system has running so many services internally, that files will be there in the SRV. Temp, that is just temporary folder. In every operating system there is a temporary folder, even if you are Mac or Windows or Linux or any other operating system, each operating system has a default temporary folder, so to keep the temporary file. Okay. Next is USR, that is user utilities applications. Whenever the user related utility application you want to install, you can install in USR. Proc, process information. Okay, so this is all about the directory structure of a Linux operating system. Okay, in the next session we will see bind, mount, volume and bind, tempfs, mount, bind, mount and volumes. Okay, because we have to take the data that is created by your application outside from the container, so for that purpose we need to use either bind, mount or volume. We will see in the next session. Okay, so I hope you like this session. Please subscribe my channel and we will see you in the next session. Till that, bye bye and thanks for watching.